Today, what I want to present is what started as a technical breakout group to define some Eclipse SDV use cases and distributions, which later on turned into a full-scale SDV project, which is a collaborative initiative between SDV technologies to flesh out what we mean by a software-defined vehicle and how these technologies play with each other, and hopefully create a collaboration sandbox between the projects to make those a lot of round pegs fit into square boxes. Today, I will try to co-present, hopefully with technology allowing, with Sven and Mario. God's willing, it will go okay. So what I want to say is basically this is two big words about the SDV Blueprints project. One is it's a collaborative initiative, so it's not providing a new technology, but it is a collaboration between these code-first SDV projects. A lot of the SDV projects, great technologies on their own, but they are not made or designed to work with each other. So there has been a lot of efforts in the last year to bring the people together and define the ways these technologies fit with each other, whether this was through trying to do, architectural work or through, different types of meetings. What we found was the best way to do this was being loyal to the original philosophy in SDV. So do it code first. So we decided to look at what we can do in terms of defining some showcases on how to bring these technologies together, because so an outsider, they all look very complex, and if you are not a part of that project, it may be a very uphill battle to bring a system up and running and see what these things do together. So that is the whole concept. So one idea was that this will serve as a place to showcase these technologies and also allow others to learn about them, run it on their own, so that we can get some feedback, real feedback from real users. So what we have done is in April, we have put in a proposal with some of the other SDV project colleagues. It was a joint proposal, and we have tried to define some initial showcases, which I will very quickly try to give you a review. And that would start the work on collaboration and see what works and what doesn't. One thing we don't know is if these are really real life or useful showcases. So a community feedback and participation is a great part of it. There will be a session this afternoon. Unfortunately, due to the circumstances, I won't be able to join, but Sven is there, Sarah is there, so please join and would like to hear your take on these things. So currently there are 3 showcases, and these are each hosted as a standalone repository. They will serve as exemplars. So currently there are exemplars on how these some of these SDV technologies fit together within that showcase. But what we'd like to see is in time evolve into documentation, a user's tutorial documentation, and also again in time, what are the best practices in terms of using these technologies. So these are the initial goals and principles. As Sarah put it this morning, it's the business card for Eclipse SDV. So if you want your project showcased, and reach a broader community. And if you want your project to work with other SDV projects, please come and join the SDV Blueprints project. Propose a new blueprint, and we only have one prerequisite, that you work with other SDV technologies. So you can go wild with your use cases, but please try to see how it works with other SDV technologies. That's the whole idea. Governance-wise, it's a regular Eclipse project. It has committers, it has repositories, it has issues tracking. This just came alive, so I think in the next couple of weeks, especially starting with the fleet management, you will see the code coming in. Initially, we have 3 use cases in the Blueprints project. We also are creating a Blueprints website, which will automatically gather documentation and tutorial materials from each one of the blueprints, and we're hoping that it will become a part of the overall SDV documentation and project websites. So each one of the blueprints has different set of projects participating. So obviously, it will have its own release schedule and packages and different ways of distribution. We also gather every month in a monthly Zoom meeting. You can find the link to this at the Eclipse SDV calendar. And it's an open participation meeting. So we'd love to hear if you have new proposals. Please join us in these meetings. So currently, as I said, the whole idea is not just to present how these technologies work together, but it's a starting place for the community in general. So hopefully these will grow, and it's currently built to create an online document of each one of the and basically quick starts and distributions for people to try. This is currently under construction. You're just seeing sort of a development view of the whole thing. And it's also a place where we can blog about each one of these showcases. Please, when it becomes available, visit this website, and we'll love to hear what you say. So I will quickly start with some of the use cases. There is a fleet management use case, a Ross racer use case, and also an insurance use case. I will quickly start with the one that I am coordinating. This basically is based on robotic operating system. It's a multi-agent system where some autonomous racers, they will use the F110 learning stacks. These racers will be orchestrated, managed by some of the SDV projects. So currently it has Eclipse Muto as the ROS orchestrator. And to manage these Muto-based stacks, it will use a in-vehicle middleware, which is Eclipse Chariot. We're also thinking different ways of converting the signals coming from these ROS racers into a format, basically VSS type signals that can also be driven through Kuxa Data Broker, which can be used to build different types of dashboards and etc. That are based on those technologies. You will also see that there are some common componentry that seems to be present in these showcases. So that will be one of the outcomes of the Eclipse Blueprints project, that we see the need, for example, to push the vehicle data and signals to the cloud applications and services. You will see this pattern appearing over and over again in different blueprints. And we're hoping that some of these components that are built as parts of the blueprints will take their place in one or many of the So it will get graduated into an SDV technology in time. There is also a need, for example, there is in the vehicle, there is a stack of software running. And today you heard one, but there are different technologies to orchestrate these software stacks. So we are looking at, again, how to connect to the orchestration technical breakout groups on finding out solutions for these problems. So if I can manage, I can pass the buck to Mario, who's here to talk about the insurance and data exchange blueprint. He also has a more detailed, I think, presentation on this later on. Mario, do you want to take over here, or should I make
Sure. I can. If you can hear me, can you hear me?
Yes, I can.
Oh, so many. So, why is this interesting for me? When I arrived to Germany 18 years ago, I didn't have a car for 10 years. Then, finally, I got a car because I had children, etc., and I tried to get insurance. Now, not having a car from 10 years and not having any kind of insurance history in Germany meant that I was hit with the most evil and high rate of insurance ever. So I have to pay a lot of money for my insurance. Now, if anybody knows how I drive like a grandmother. So the whole topic of paying how you drive insurance is a topic that is relevant for a lot of people. And it's a topic where there is a potential to have a lot of business, if you will. Now, today, it is possible to do pay how you drive insurance by putting a dongle or a tag in the vehicle. And this is the way that you can more or less monitor how the people are driving. This has a lot of issues. One of them is, of course, the dongle costs money, which means that in a very highly competitive situation in insurance, is a problem for the business. The second issue is that they are not very precise. So the data quality from a dongle connected to the car is not going to be that good. Now, the cars themselves have a lot of sensors. And in theory, it is possible to get a very clear view on how people drive based on the sensors of the car. So that's quite clear. And here is where we face two problems. Problem number one, the way that you collect data from the car and how it's used to evaluate driving events is not standard. Problem number one. And problem number two is, how do you share the data from a driver that authorizes that, for sure? How do you share the data from a driver with people, with the insurance companies, in a secure way that is compliant with all of the different regulations that we have in Europe and in the United States and worldwide? So we have these two categories of problems. So what we are trying to do in this blueprint is demonstrate how an insurance company can collaborate with automotive companies and tier ones in order to create two things. First is a definition of what events are relevant for risk evaluation, and do this data collection in the car. So instead of streaming a lot of data from the vehicle to the cloud, we just want to snapshot the risk-based events. And we have a list of 25 risk events that are relevant. And these risk events will go, of course, into the telematics platform of the OEM. And from there, they go into a data landing zone. And there is a second Eclipse project, which is called Eclipse Data Spaces, which is all about data sharing in a secure way, decentralized between different instances, in this case, a telematics provider and an insurance platform. So as part of this blueprint, what we are going to do is not only look into the car using technologies like Chariot, Ibegic, Cuxa, etc. It's not fully defined. It's not only about doing the snapshot in the car, but also structuring the data in such a way that we can leverage projects like Eclipse Data Spaces as MQTT to send this information to the cloud, process it, and provide it to the insurance companies in such a way that they can calculate a risk score. So this type of project or concept of pay how you drive insurance is nothing new, but we want to leverage here the power of the community, in order to create a case that can potentially work for all of the stakeholders and participants. And of course, taking advantage of a code-first approach to have a foundation. It is very early days, but I want to bring some, we are working, of course, with insurance companies. So we want to bring some insurance companies as stakeholders and participants on Eclipse in order to work with them and help, have them help us, help them create this use case in the right way. That's it. Thank you.
Okay, thank you, Mario. And I think I will sort of maybe give the mic to Sven, who's on site right now, to give information about the fleet management use case. Sven?
Yeah, I'm not sure how the audio handover works, but I just continue speaking. I had another slide deck uploaded to the SharePoint or Google Drive. Maybe continue with that.
Okay.
So here. You didn't have a video. You didn't have a video. Aha, okay, that's different. No. He has the video. It's different. No, it's not here.
Then you can see. Okay, it's fine. It's fine.
Do you want to share? Send it again.
We didn't have any issues then. That would not be something difficult, right?
Yeah. So I'm not sure if the rest of us can see it. Not yet. I guess it.
That helps.
Sometimes it does.
Yeah.
Here you go. Yeah, so also warm welcome from my side. I will talk about the third blueprint that we're proposing, and we hope to have it maybe public in the next months. It's about fleet management. I think we had quite a similar idea as Naci was introducing before, because we thought there's a lot of different technologies out there, a lot of puzzle pieces, but we actually wanted to have some, let's say, skeleton to try out these different technologies. So we were looking for a use case which is common enough to work on that, and we figured out that blueprints, or not blueprints, but the fleet management might be something interesting. Because the problem statement that we see here is many fleet operators are sometimes even legally required to collect certain data points out of the vehicle into a fleet management system, or in this case, FMS. So the question is, how do we get this specific data out of the vehicle in that case? And the problem becomes even larger because every operator of such a vehicle might have a different backend requiring a different data standard, and also having different ways of getting the data out of the vehicle, because every vehicle and every OEM might do it differently. So this can become really costly for basically everyone involved. First, the OEM, because they have to support multiple ways of extracting the data, the operator, because they need to align to their backend. So I guess there's some way to overcome the situation. And the idea is to have more generic ways of getting to the data. So you have like this really different, deeply embedded layers, different CAN stacks, SAM-IP stacks, however you want to call it. But in the end, you have the same abstraction layer. In this case, we'll come to that in a second. We use Coxer for this abstraction. And from there, we can also upload the data to the cloud. That's different. And then from the cloud, it's possible to retrieve the data again over other standards. So in the end, we can use standards used by all the backends and these backends do not care how the data actually got in there. And that's exactly the idea of this fleet management use case, to showcase how we can go from the deeply embedded layer up to the abstraction into the cloud. The question, of course, is how do we do that? And so first of all, another slide about hardware abstraction. So I think this is the central piece also of this blueprint, because here we used the abstraction of VSS, so the vehicle signal specification, standardized in Covesa. Unfortunately, I forgot my Covesa button today. But to actually use it as a running software, we have Cuxa, or more specifically Cuxa-Val, so the vehicle abstraction layer. So all the deeply embedded layers can provide the data to the Cuxa data broker in this case, or a component from Cuxa-Val, and on the fly convert the data to the VSS data format. And from there, other applications can then consume the data. And putting this into the larger architecture picture, I will explain it from the bottom to the top. Again, we have our data source. And in our blueprint, we decided, because it's quite specific what kind of data sources you have, could be some IP, could be CAN, whatever else, to have more generic format, because we introduced a way of recording signals as a CSV file. So then the data is replayed from the CSV file. So you have these different signals and the timing information about the signal, and then you play this through the CSV provider into the data broker. Then the data is available in the data broker, and it's nice, but it's not the place where we need the data. So how do we get it into the cloud? And that's where we came up with a custom implementation, basically subscribing to the data broker, getting the data out of there, and forwarding it into the cloud. And cloud in our case means we have an influx database as a time series database to store the data, and two different ways to get there. So the first way is the direct way. It's simply writing from the FMS forwarders through HTTP into the InfluxDB. But we figured this is maybe not so well scaling. So we also have the way to use Eclipse Sono, which is a well-proven project from the Eclipse IoT community, specifically done to do the transport of data between IoT devices, like the software-defined vehicle here, or into the cloud. Yeah. And the other nice thing here is, once we have the data in the cloud, we want to make it available. So we either have a FMS server, which is basically using the InfluxDB as a data source, and from there making the data available through the RFMS interface, which is an external standard. So by this, we can integrate with existing backends, because these rely on this standard. So this way, we add another level of abstraction going into these existing backends. And also for demos, it's a bit easier not to have the HTTP API, because on an HTTP API, you don't see that much. So we also added a Grafana dashboard, which is a quite nice overview of what is going on in your vehicle. So in the initial step, it's basically your CSV recording, but you could also imagine to use other providers, for instance, a CAN provider, which then would be plugged into an actual truck, then listening on the data on the CAN bus, and then from there forwarding into the data broker. And then we still can use the same architecture that you see here on the slide. So that's some of the beauty that we have in this blueprint. We don't do this blueprint just we do it for fun, but not just for fun. There's also another motivation. One motivation is also to look into how could you actually extend this really basic idea or this basic architecture. So one topic that we had quite some discussion in other meetings of the SDV working group, and also when coming with this architecture, is how do I actually get simulated data, or how do you actually test my application against something? So we wanted to integrate a simulation, in this case, another Eclipse project called Eclipse Sumo. And what Eclipse Sumo is doing is you can simulate almost a whole city these days. It started more for simulating crossroads or something like that. And we then subscribe to this vehicle simulation and write the data again into the data broker. And since we now again use the same abstraction of VSS and the data broker, the other layers on top of the data brokers do not care whether the data came from the CSV recording, from the simulation, or some other arbitrary source. That's something we might also add to this blueprint later after the initial release or the initial commit. And in this fashion, we are really looking for other contributions, some other ideas on how you could extend this basic setup. So this is just an ideation slide. So we could think of having a CAN replay using maybe J1939. So it's a bit a matter of also the license situation here. Once the SUM IP or Summer is available, it could be also a really nice addition to have some Summer reader provider here providing actual data to this whole setup. We also did some work, some ideation regarding Chariot to actually orchestrate different services in the vehicle. And I guess this is just a starting point. So I'm really looking forward also to our session in the afternoon. Maybe you find other logos, other boxes that we can add here. One thing which I actually forgot to mention is we also split the whole blueprint into two parts. You can already see it on the slide on the dotted line. So we have the in-vehicle part, which is really running in the vehicle. Obviously, that's why it's the in-vehicle part. And we have the off-vehicle, or let's call it cloud backend. And in the initial setup, we provide a Docker Compose file. So you can just run up everything on your local machine and start developing there. But we also envision a scenario where you run the in-vehicle platform or the in-vehicle part in Leder. So that we can configure Eclipse Leder and also the Eclipse Canto runtime in Leder to run the containers in the vehicle and then still consume with the same backend of the vehicle orchestrated by Docker Compose. That's another thing that we're working on. And with that, I'm through to this blueprint, and I think we can open the floor for questions regarding the general concept, or of course, to all the three blueprints. Thanks.
So any question from the audience? So maybe one more advertisement. So I cannot stress enough how important this initiative is, and please try to join. So the Blueprints group is meeting monthly to gather new use cases, to discuss on use cases. So please think about how can your project be integrated in one of the already existing blueprints. And if in case it is not, think about a new use case where your project would fit. That's really important for us because it's the first time we try to do an overarching project. So any question from the audience? Maybe
comments, ideas?
There are questions online? No. Okay.
There's one in the room, and the mic is just on its way.
Hi. Can you please go to your architectural diagram? So yeah, thank you. No, I think it was some another diagram. Sorry, the last, yeah, this one, thank you. This FMS forwarder, it has this communication with MQTT, right? And you have in between cantos. Why it's not communicating directly to the other Hono MQTT broker service? So why you have a connector in between?
I get the question. So this is the whole picture is, let's say, under construction ideation. So don't take it too serious to granted. The reason why this is here is Canto is actually doing multiple things. So many people, and this is also how we perceive it in the SDV space, is mostly Canto used to manage the container or the container execution. What Canto is also doing, and I like the term in the previous presentation, it has a so-called cloud connector, which is basically working in Canto the way that you have a local MQTT broker run by Canto, and then all the applications managed by Canto communicate over this MQTT broker. So now, of course, the question is, how do these applications then communicate with the cloud? And instead of making their own channel up to the cloud for each and every application, there's the option to have a specific application, the cloud connector, who does this cloud connection. So it basically subscribes to the local MQTT broker and then forwards all the messages it sees to Eclipse Hono in this case. That's the reason why we have this specific Canto box, because here we talk about this cloud connector.
Thank you.
If I can add something, I don't know if you guys can hear me. Can you hear me? I think this is the part where I mentioned that one of the outcomes of the blueprints is that we start seeing these architectural components in the blueprints that seem to go across all the blueprints. For example, this it's called FMS forwarder here, but there are components with similar requirements in the other blueprints too that handle the cloud communication using some type of protocol. Here it's MQTT, but why not U protocol, for example? So we're looking into gathering these requirements from these blueprints and also see if we can share these solutions between the blueprints. So all this feedback is really important to us.